we can just start with what the project actually is and why was it initially created?
Oh, starting with
Those
the
are
hard
two
questions.
difficult questions, yeah.
Yeah, it's a long story.
What
It's
it
a
is
long
easier,
story.
I think.
Hopefully, I will get to the end of it before you collapse from the heat. So, so basically, it started because I thought I will not get in trouble
Mhm,
writing this project. So it went wrong from the day one. So it started when I was working at Intel.
mhm,
So I was working at Intel on a certain project, which okay, it will remain unnamed. Let's call it Project X.
sure.
I worked on Project X with, and those two guys are important for this story. Alexander Lyashevsky and Alexei Titov. They
Mhm,
are grandfathers of this project. So work at Intel. It was a so some details I can provide.
mhm,
So it was a project, certain GPU library for a certain workload, for obviously
mhm,
Intel GPUs. Um, was one of the first projects actually using Intel SQL implementation
mhm,
called DPC++. So we can think of it as sort of Intel's answer to CUDA. This was a very early version of SQL, and we had a lot of discussion about, well, how useful it is, how good it is, and there one of those discussions or arguments. I don't remember who, Alexander or Alexei, told me something that stuck with me. Is that
mhm,
okay? SQL might be good, might not be good, but what our Intel customers want, they want CUDA. They
mhm,
want CUDA. They want CUDA on Intel GPUs, and I don't remember what we discussed in detail, but it really finished this discussion. So he was right. I had no comeback from this,
mhm,
but the thought stuck with me. So time passed. The project X was cancelled, and I started working as a manager.
mhm,
As a manager, I had almost no opportunities to write code, and it started to become slightly frustrating.
mhm,
If you don't write code, you sort of become mm, every day you get slightly more diverse from the daily realities of writing code, especially if it's a Intel GPU code, where at the time, so it was pre what is the public name, Alchemist.
mhm.
It was still in flux, still moving
Right.
quickly. So I was getting a little bit more frustrated, and 2020 came in. With this COVID, we're all stuck inside our homes, uh, me included. And at the same time, uh, Intel, when it comes to Intel GPU development, started moving to a different host code library. So
Mhm,
previously, most of the development used OpenCL, but OpenCL is relatively high level, and if you want to have some kind of extensions to OpenCL, you have to some degree negotiate with other vendors. So
mhm,
you don't create something that is useful to you, and another vendor comes something useful to them, and there are just very minor differences.
mhm,
So Intel came something we've called level 0. This was the new premier way to write host code, and it looked fairly good, and we're all just starting to use it, starting to learn it, and I wanted to know more about it. So in my mind, I had two choices: either resurrect Project X, which was cancelled. I was specifically asked not to do this, not to do this in the open source, and I thought, well, okay, if I do this, I'll get in trouble. And there's another project I thought would be interesting. implementing CUDA on top of level 0. And my thinking at the time was, okay, well, what I really wanted to do was learn level 0, understand how it works, what I can do with this that I cannot do with OpenCL. Um, if it works, well, it's not going to work, but if it works, it's going to be very cool. So I started working on it, and I worked on this through most of the 2020. And well, that's how Zluda came to be. Surprisingly, it worked. Surprisingly, it reached decent performance, and I released it sometime late 2020.
What would be decent performance in your mind? Like, if you were to take an equivalent Nvidia GPU and an Intel GPU, like, what percentage of the performance were you sort of getting at?
Right. So this is a difficult question. It's very
I guess it depends
difficult
on the workload. Yeah.
difficult to compare the performance because you need a workload where you have implementation, native CUDA implementation, and OpenCL implementation that works natively on Intel. So a good target was Geekbench. That's why Geekbench was pretty much the only thing that was working. So in my mind, something like 80% of the native OpenCL performance would be really good, surprisingly good. I don't remember what was the exact performance. It was like something like 90%. So Geekbench is actually a suite of tests. So surprisingly, some tests were even faster than the native versions. Some
Wow.
were slower, but the performance was, I think, around 90% overall, which was much better than I expected.
Well, it's much better than the alternative, which was 0.
Yeah.
So, for anyone who may be unaware of what Zluda actually is, like, at a high level, can you just explain, like, what the general purpose of the project is?
Like, general purpose of the project is you have your software and your software doesn't work on your hardware. So Zuda makes your software work on your hardware. That is.
Okay, maybe
And
a bit lower level than that.
Yeah. No. But, so you understand what is the good about this project, and specifically targets applications, libraries, whatever, plugins using CUDA. And the reality is, if you have your GPU and maybe use your GPU for gaming, which is horrible. Why would you do this? GPUs were meant to multiply matrices. GPUs were meant to calculate chemistry and physics. So if you have a gaming workload, well, if you have a game, then you're going to use a specific API to do things that game do. I don't know what they do.
Generate polygons.
So things like DirectX, Vulkan, OpenGL. But if you want to do computations, so physics simulations, chemical simulations, whatever, machine learning, then you have specific APIs for compute, and by far the biggest one is CUDA. And think about CUDA, it's written by Nvidia, it's created for Nvidia's GPUs. But it turns out, and this is what Zluda does, you can implement the sort of the runtime environment of CUDA and then run some other GPU from another vendor. You can use your application on another GPU, non-NVIDIA GPU. From the perspective of the application, it's a normal NVIDIA GPUs. It's slightly strange, has a little bit strange configuration. Some things doesn't work, but from perspective of an application, it's the same. It's similar to how Wine works,
right.
on Linux. You can run Windows applications on Linux.
So there's something I was going to say.
And then okay, and
no,
maybe,
I had something. I just completely blanked on it.
Lower and lower level explanation. So if you have CUDA application, so for those of you who wrote CUDA, they might be thinking, okay, how is it possible? Because if you write CUDA is also CUDA is many things, but other than the runtime environment, it's also a programming language.
Mhm.
So you write your program in CUDA. It's a dialect of C++, and you can you can mix GPU code and CPU code.
Mhm.
But
Mhm.
this is an illusion, because what happens at the end, at the sort of bottom level, and that's where it lies, you have it's a normal application which calls into NVCUDA DLL or libCUDA SO. It's a normal application which uses certain functions provided by a certain library. There's no magic. And if you implement this runtime driver library, then you can then you have Zluda. Zluda implements this library, and this library can be relatively complex because you need things. Uh, so what runtime library does, it allows you to control your GPU. So you can query your system. Okay, I have GPU number 1 with this name and with this much RAM with this, and you have this many flops. I have GPU number 2 or 3, and on this GPU I can allocate memory. On this GPU I can execute a computation. So runtime also contains a compiler for virtual assignment. This is a bit more complex, but you have to also provide this,
Mhm.
and Zluda does it.